condition to be true to the other step 3-4 after 10 ms also for this step to coil 1 2 I meant. Okay, now we'll do the same with this other step. If we want our stepper to move in a uniform way, of course we are going to put the same timing in every step, which in this case we choose, just as an example, 10 ms. So we select the delay operator and we connect it to the variable. Okay, now it remains the last step. In this case, we need coil 1 and coil 2 to be true. Again, coil 1, coil 4, sorry. And again, we select 10 for the delay operator. So now we have designed the data flows for all our coins. Now we put another step here, and we call this step manager. This step is going to manage the behavior of our stepper motor. In order to give to the conditions we have specified between the coil steps the values we need. We choose this model for the video tutorial because it allows us to show at least the main operators of TaskScript technology. In this case, we are using the comparator operator. Actually, I have chosen a bit variable for current. That is why the comparator was not working. What we need is a word variable. We call it current and we give the proper allocation to it. Now the operator is going to work. This is because this methodology tries to understand when we do those kinds of mistakes, and it does not allow designers to do them. This operator compares the value of the variable current with the value of the variable target. Compare operators are equal, not equal, greater than, or equal to, less than, or equal to. They operate with arithmetic variables and produce a Boolean result according to the comparison. Their component level counterpart is the arithmetical comparator. Of course, we can connect our variables to more than one comparator. And also in this kind of data flow, we can select the path we need for the line that connect variable and operators. So forward is true when current is less than target, and back is true when target is greater than current. I believe that this kind of graphical modeling is clear enough to be speaking for itself. So now we are using another operator, which is just a logic operator. In this case is an OR expression. So when the output of those comparator is true, when just one of them is true, the OR operator is true. We connect it to another logic operator, which is the AND one, and now we have just put an edge operator. The edge operator allows to use the value that a Boolean variable held during the previous scan, and in particular, it returns true if and only if the variable experiences a rising edge in the current scan. For example, if the variable was false in the previous scan and is true in the current scan, or the other way around. We have put a store option. This is the only way for allowing our edge operator to work, and we have connected it to the end count variable. So the end operator we see on our right is true when end count goes from false to true. Now we have put another kind of operator. Which is the choice operator, which allows to choose among a number of alternatives in the assignment of a variable. It operates with either arithmetic or Boolean variables and produces a result of the same type. It is enforced that all the variables that are being chosen from are of the same type as this result.